Hello everyone, I am Dr. Naresh Kumar, Assistant Professor from the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today I am going to explain about the question bank discussion on AC voltage controllers and cycloconverters. So in this total 20 questions, first question is explain the operation of single phase AC voltage controller with RL load. So here we can two types of controllers, AC voltage controller. So here half wave and full wave. So in the half wave we will use only one diode and one thyristors are connected in parallel. In the full wave we will use two thyristors connected in parallel. So this is a circuit diagram for half wave single phase half wave AC voltage controller. So here I am using the load is the R and L load. So this is the circuit diagram. So here I am applying the supply voltage V equals to Vm sin omega t. Here it is the maximum voltage, and here how we will get the output voltage. So here, so first waveform here from these are the modes. First from the alpha to pi, and next pi to beta and beta to 2 pi. So first here from the alpha to pi. So here this thyristor is in forward conducting mode and diode is in reverse bias. And next here pi to beta. So this T is the another thing is here. First one is a 0 to omega t to alpha. So the thyristor is in the forward blocking mode and diode is in reverse bias. So it is in forward blocking mode and diode is T is forward blocking mode and diode is in reverse bias. This diode forward blocking mode. This diode is forward blocking mode. And next alpha to pi. So this thyristor is in forward conducting mode and this is in reverse bias. And next pi to beta. T is forward conducting mode and D is also in forward conducting mode. In this case, V naught equals to Vs. Here is also V naught equals to Vs. In this case, V naught equals to 0. And now I naught equals is also 0. And next beta to 2 pi. So now here diode is in thyristor is in reverse bias and diode is in forward bias condition. Here this is alpha to pi range, and next to this is up to beta. This is 2 pi and beta. So these are the up to beta. Here it is up to beta. So this is for RL load. This is the waveform for RL load of wave. So here you can use for full wave. So you can use two thyristors. That is full single phase full wave bridge converter. And next here second one is a demonstrates the effects of load inductance on the performance of AC voltage controller. So these are the effects. First effect is the phase shift effect. So when inductive load is on single phase AC voltage controller. So here what are the load? Inductive loads are transformer or motor. So it is connected to the any controller or any converter. What will happen? The current lags. So inductive, what is the current lags voltage by some angle. So that is lagging angle. So that current lags voltage by some angle. So that causes the phase shift. So this can lead to the lower power factor and higher harmonic distortion. So here there may be effect on the phase shift. And second effect is the output voltage is also changes. The output voltage of the converter or controller can be reduced by the presence of source inductance and load inductance. So this is because of the load current reduces, the output voltage reduces. And next, commutation overlap also. This source inductance can cause a commutation overlap period, and where all the thyristors conduct simultaneously. So now during this period, the load current freewheels through the thyristor, which reduces the average output voltage, and next SCR is also fails. So for very large load inductance, SCR may not be able to commutate after it is triggered. So it may fail to turn off the SCR. So now here this results the whole load voltage being a full sine wave, and output control is being lost. And to reduce these effect of load inductances, additional measures may be required, such as the inductor control method is required. And next here, third question, AC voltage controller. Third question, explain the operation of AC voltage controller with R load using circuit diagrams and waveforms. So now here in the first question I have discussed with RL load single phase half bridge, but here I am explaining full bridge. I am explaining so two thyristors T1 and T2. So in the first 0 to alpha, 0 to alpha, 0 to alpha, this is complete sine wave. I am giving the Vs equals to Vm sin omega t. Now here supply voltage I am triggering at alpha. So 0 to alpha, T1 and T2. So T2 is in reverse blocking mode and T1 is in forward blocking mode. So both are in off condition. This is off. So output voltage is 0 and output current is also 0. And in the second mode, in the second division, in the second mode, alpha to pi. So T1 is in forward conducting mode. If I am giving the triggering pulse to the T1. So what will happen? So here in this case, Vs is greater than 0. And Ig is not equals 0. Here I am not giving any gate pulse to the T1. So now here T1 is forward conducting mode and T2 is in forward blocking mode. In this mode, what will happen? Output voltage follows the input voltage, so that this is the output voltage. And next here V0 equals to Vs, and next I0 equals to V0 by R. So this is the output current. And next, what about this after pi to pi plus alpha? This pi to pi plus alpha, T1 is also comes back to the reverse blocking mode, and T2 is in forward blocking mode. In this duration, so no thyristor will conduct. So here T2 thyristor will conduct, but it is in forward blocking mode, not in forward conducting mode. So now here in this case, the output voltage is 0 and output current is also 0. And next at pi plus alpha, what will happen? At pi plus alpha, T2 thyristors will conduct. So T2 is in forward conducting mode. And next here pi plus alpha to 2 pi. And now T1 is in reverse blocking mode. So now here in this case, so it will follows the output voltage, input voltage. Output voltage follows the input voltage. Output current equals to this V0 by R. So V0 by R. This is the output current. Now here is the case for full single phase. So I am using two thyristors, full bridge, full wave, AC voltage controller. If I will use here, that is diode, that is of single phase off wave AC voltage controller. So now here next, AC voltage controller off wave bridge. This I have explained now. Now fourth question. Explain the principal operation of on and off control used in the AC voltage controller. On and off controller definition. What do you mean by on and off controller? Is defined as a control system is fully open or close the control element when the process variable crosses the preset value. So now here the principle of on and off controller works on the fully closing and opening the output value, the causing the process variable to the change duration, the cycle continuously. So examples are the Same here. So this is for the case for transformer, but here on off control. So this question is also already we discussed in the theory part. So on and off control used in the AC voltage controller. And next here, summarize the expression for power dissipated in the AC voltage controller with RL load. So this question is also we have discussed in for the continuous conduction current operation is also. And next here, categorize the different modes of operations of triac. So what are the operations? So triac is having, so here this is the triac. So this is triac. So this is one. So here we have how many terminals here? So MT1, T1 and T2 and 2 gates. So now here mode 1 is the T2 terminal, T1 and T2 terminal is positive and gate is positive. And next mode 2 is this is a mode 2, and next to T2 terminal is a positive and gate current is a negative. And next mode 3 is the T2 current is a negative and gate current is a positive. And mode 4 is the, and next terminal 2 is a positive and next gate terminal is a negative. These are the 4 modes of the operation of triac. So this triac can be used in the AC voltage controller. In this is the actual diagram is here. So this is the triac. So V equals to Vm sin omega t, T1 and T2. In place of 2 thyristors, so triac means 2 thyristors are connected in parallel. So this operation, this can also we can connect in case of AC voltage controller. In this case, also same operation, same output voltage waveforms also we will get in case of AC voltage controller using triac. So now here, so develop the expression for input power factor AC voltage controller using on-off controller. So now here, what about the P input equals to P output? So input voltage, input power factor formula is here V input equals to IS, Vs into IS into cos phi and V naught square by R. So now here output power equals to I naught square into R. So but I naught equals to I naught RMS. So now here I naught RMS square by into IS. So here this one is IS, this one is gets cancelled. So I naught RMS into R by Vs. So now V naught RMS by Vs. So this is common for all converters, AC voltage converters. And next here, explain the operation of AC voltage controller with triac and draw the input and output waveform. So this diagram is also same in the previous one. Here this is one, and next here this is the triac. Here there is a load, R load, RL load and RLC. Now this is the triac. Triode for triode for alternating current. And now here this is V equals to Vs equals to Vm sin omega t. Here this is the input voltage waveform Vs, Vm, Vs, and next output voltage is for R load is here, and next again same. So this is the output voltage waveform, same as that single phase AC voltage controller using 2 thyristors connected in parallel. Same as for triac also, single phase AC voltage controller with triac also same. And for RL also, what are the limitations of cycloconverter? First one is the harmonics and output voltage. Cycloconverters creates harmonics in the output voltage waveform, so which causes the harmonic losses and torque pulsations. And next, second limitation is the output voltage. The maximum output voltage is limited to the 86% of input voltage. And next here, power factor have low power factor, especially low power factor output voltages. And next here, control circuitry, and this circuits, cycloconverters have complex circuits, complex control circuits, and semiconductor switches here. This controls cycloconverters requires large number of semiconductor switches for higher power ratings. And next, there may be commutation. Cycloconverters have commutation challenges at high output frequencies in the step up mode, power factor, control circuitry, semiconductor switches, commutation, and that last one is a regenerative braking. Cycloconverters are not suitable for regenerative braking applications. So this is one limitation for cycloconverters. These are the limitations. 1, 2, 3, 4, 5, 6, 7. Now here, 10th question. Explain the operation of single phase midpoint step down converter with R and RL load. So here you can use R and RL load. So two thyristors P1 and N1, and again two thyristor P2 and N2. So these two are connected in parallel, and these two are connected in parallel. So this is positive and negative, positive thyristor and positive side, negative side. Here I am using the one center tapped transformer. So next here, supply voltage I am giving. Here you can use loads R or RL load. Output voltage I am getting here. So now here, these are the output voltage waveforms. So here VA0, VB0, and VA0 and VB0. So two output voltages. And now here output input voltages, and these are the output voltage waveforms. Output voltage waveform and output current waveform. Now this is for discontinuous mode, and now here this is discontinuous mode current conduction, and this is for continuous conduction. There is no discontinuous. So here input voltage waveform, output voltage waveform, output current waveforms for both RL and RL. And now here, explain the working of single phase bridge type step down chopper with RL load. So this is bridge type, not step down converter type, bridge type. So that is RL load. So these are, here I am using positive converter, positive group converters, and negative group converters. So bridge type, this is full bridge type inverter, cycloconverter. And now here, this one is also, I explain what are the salient features of cycloconverters. So that I will explain in the next slide. So that is also we have demonstrate the operation of single phase midpoint. So this one is also midpoint, that also we have discussed that operation, that output waveforms, and R and waveforms also, output waveforms also we have discussed, and interpreted the merits and demerits of the cycloconverter. So this is also, I think, 13th, 12th question. So what are the advantages? So here the advantages of cycloconverters are here: efficiency of cycloconverter as compared to the other converters. So this efficiency is very high. Efficiency is high compared to the other converters so that are available. So AC voltage controller, inverters, other type of converter, as compared to this cycloconverters, efficiency is very high. Capable of power transfer is bidirectional, not unidirectional. AC power is at cycloconverter operates at with a distorted output, and if SCR fails, the SCR converter operates it's distorted output, and power transfer is possible from the source to the load, vice versa from the load to the source. So that is the bidirectional. So this one. And next, at any power factor condition, this is one major main advantage of cycloconverter, and dynamic response is very good, and smooth low speed operation we can achieve using cycloconverter. And what about the demerits, disadvantages of cycloconverter? So complex circuits, thus it is difficult to design. So here more number of components are required to build the cycloconverter, and the output frequency is limited to 1/3 of the input frequency, and also power factor is too much, very much poor at low values of alpha, and there is more distortion at low frequency, and smooth output frequency is very difficult to maintain. So these are the demerits, and next these are the merits. And now here 15th question, compare the operational features of single phase midpoint and bridge type. So in the midpoint type, so here this is a circuit diagram. So this one is here one center tap transformer, and here is a load, and here is also same here and here, and next here this one, and here is another transformer, and here I am giving here VES and V0 I am getting, and next here one positive group converter and negative group converter. I am connecting load here in between, and I am connecting supply. So that is midpoint. So that is also we have discussed in the previous lecture. And now here explain the working of single phase bridge type step down chopper with RL discontinuous conduction mode with the help of circuit diagram and relevant waveforms. Also we have discussed in the class in the previous lecture. Explain the salient features of cycloconverters. So these are also we have discussed here. First one, if it is efficiently, the efficiency is high. So bidirectional from the source to the load and load to the source at any power factor. So here smooth speed operation is we can achieve, and next dynamic response, and if SCR fails, cycloconverter operates with the distorted output waveform. So these already we have discussed. And next thing here, explain the operation of bridge type step down cycloconverter with R load, and so this one. So this one is also we have discussed in the previous lecture. And next here 19th question, demonstrate the operation of single phase midpoint cycloconverter with R and RL load, and draw the need diagram. So this class also we have discussed, just go through that video in the previous lecture. Next last one is illustrate the operation of step up cycloconverter. These are three types: single phase to single phase cycloconverter, three phase to single phase cycloconverter, and three phase to three phase converter. So this question is also, this one is also, this topic is also we have discussed in the previous lecture. I hope all these questions are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. These are the reference books you can go through. First book is a P.S. Bimra, and second book is the Rashid book. So this is the Pearson Education, and next Khanna Publications is a Bimra, Umanand book and Mohan, and these 5 books are reference book. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.